Hello everyone and welcome to a new devlog for my game engine Maraton. The timeline is kind of messed up now because I've already released the engine, but I still want to go back and give some insight to what I had to do in order to get things ready and also introduce some systems that I haven't talked about before. One of these new systems is the Debug System that introduces new ways of debugging your application built in Maraton. It can be you not knowing what happens during a frame of your game, and this system allows you to go back in time and basically look and dissect a frame, look what happened within your code. Also with memory, like who allocated what and who freed what, and this can help in some cases of finding really tricky bugs that appeared in your game. So in order to start using this system, what you want to do is go into your build configuration and toggle the Maraton Debug flag to 1, and then you can build the system. When you then go ahead and start your application, you will now see a debug button in the top left corner, and this allows you to interact with the debug system. So here is a way for you to just specify flags for your application. This doesn't do anything now, but you can imagine you can toggle like drawing certain things by toggling this on and off. Next up we have the profiling system, which records what happens during an entire frame and keeps a backlog of what happened several frames before. And this is very powerful, as I said, because you can pause and you can go back in time and look what happened. So if you have a slow frame some time ago and you didn't actually catch it in the debugger right away, you can go back and investigate what happened basically. Last but not least, we have the memory system, which allows you to investigate what was allocated and when and where during your application's lifetime. And it can be really nice to see who freed, who allocated memory, and if you have some nasty memory bugs, this can help you. Okay, so next up I want to talk a bit about the UI system within Maraton. So in front of you, you have a bunch of example applications that showcases some of the primitive controls that's often available when you're building your own UI. This often includes buttons, checkboxes, radio buttons, and input fields, as well as sliders. And what's interesting with this is that these are not something that's just made up by computer people, so to speak. It is actually something that has their own analog counterparts used in older analog systems. The reason why I'm mentioning this and showing this is because that when you're building an application that has a graphical interface, it's very important to not defy the normal and standard rules that we often see in the analog systems, because this can be confusing for your users. However, a very important thing there is that sometimes you might have to or need to step away from the standards and do something new in this space. A good example here is, for example, a normal input field where you're writing text. Sometimes you just want text, but sometimes you have to alter the rules there because you maybe just want file names, or you maybe just want dates. And this is something that I wanted to mention because it's one of the key parts that I had in mind when implementing these systems. So when starting your new implementation of a UI system, you're basically already at a crossroads where you can decide whether to implement it as a retained mode system or an immediate mode system. So the retained mode system is the one that is most commonly used and popular among most UI frameworks out there. And the word retained comes from that the system itself retains the state of the UI across frames. And the idea of this is that along with the state, the system also retains the data and the objects used to build up the scene. So basically this type of API or library often hides the details from the user and allow them to instead interact with it through some API that's indirectly manipulating the UI. In the other camp, we have the immediate mode style that has grown in popularity in recent years. The name immediate for a system like this comes from that The code in order to define the interface is the same code that also checks for interactions and does the rendering. This often means that there is no state that's backing the UI, and everything is instead happening immediately. And this is often adopted by game developers and smaller projects because how simple it is to get into and get started. Because of my old UI system also being immediate mode, I decided to go with a new immediate mode system as well. But the old system had some flaws though, because it was using a discriminated union as its backing type for the different widgets. So that means that every time you wanted to add some new type of control to the system, you would have to add a new type as well as a new struct within the UI to separate these from the other types. And this is a big problem because every time you want to do something new, that meant you had to modify the UI system itself, and I really don't want that. I want the users of Maraton to be able to use it without having to go into the engine and modify it even while they can. So what the new system that I've implemented does is that instead of separating widgets per type, it actually builds up each widget based on different properties. So for example, a widget can have text to be drawn, it can have a background, it can be editable or draggable or clickable, but you can combine all of these different properties instead of defining, a button, a slider, etc. This is actually really powerful because it gives the user of this API the opportunity to build basically any widget they want and define the behavior of it as well without modifying the core of the system. Another very important thing to mention is that this system is a mix between immediate mode and retain mode, because this system actually does retain some state across frames. It stores every widget in a local cache and only updates it once a widget is no longer used. And while caching these widgets, it actually builds up a sort of binary tree between the parent and children relationships of all the widgets, and this allows us to actually perform some quite advanced auto layouting. What I mean with this is that because we're building up this tree, is that we can make assumptions about a widget's size based on its parents and its children as well as itself. The result itself is quite satisfying, and with the engine I'm shipping examples that showcases how to use it and what it can do. For some more in-depth explanation you can visit my website. That is it for now. Thank you very much for watching. Don't forget to like and subscribe. Goodbye.